Hello students, today we continue our topic of chemical properties of alkene. In chemical properties of alkene, we already discussed about the electrophilic additions reactions. Then we discussed about the oxidations reactions of alkene. In oxidations of alkene, first point is a full combustion reactions. Number 2 is a controlled oxidations, and these controlled oxidations in presence of oxidizing agent like cold and dilute KMnO4, which gives, or the reaction is also called as an hydroxylation reactions, and which gives vicinal or 1,2 diols, and then oxidations with hot KMnO4, which gives a carboxylic acid. In these reactions of oxidations with hot KMnO4, which can also subclassified into two parts, with terminal alkenes and with non-terminal alkenes. After that, the most important point, it's the oxidations of alkenes with ozone. So it's called as an ozonolysis reaction. In competitive examinations like JEE and NEET, in many particularly papers, the question asked from these portions too. First, we have to discuss a depth of what is the ozonolysis reactions and why this ozonolysis reactions is important for us. Firstly, it's a one type of additions reactions, definitely. So when ozone, this particularly ozone O3, right, is passed through a solution of alkene in some inert solvent like dichloromethane, or sometimes we have to take a chloroform or carbon tetrachloride at very low temperature, near about 200 Kelvin. So this particularly ethene is oxidized into ozonides compound. And these ozonides compounds are highly unstable in nature. So they are not stable in nature, they are unstable in nature. How the reactions can particularly participate? Your ozone having such a type of structure, as we know that ozone having a resonating structure, right? This is minus, plus, and the resonating structure. This ozone which can be land over this ethene, and we get a CH2O, CH2OO. Right, so here CH2O, CH2O, and this is O. This is a peroxo group, one type of peroxo group. So these ozonides compounds are unstable and they are explosive too. Therefore, they are not usually isolated. But it can be reduced in situation. In situation means you cannot take particular ozonide by means of, you cannot isolate the ozonide compound, so we have to perform the reactions through or in situations with zinc dust and water, so which gives aldehyde or ketone or both. So here there is a cleavage because this is CH2O, so it's a reductive cleavage. The CH2O means HCHO and another CH2O means SCSO, so we get a methanol as our product. This particularly mixture of reductive cleavage, okay, so this which is based upon depending upon the structure of alkene. For example, if I having a propene, so additions reactions of ozone at double bond, definitely, so we have to write like that CH3CH, right, then OOO, so we get a propene ozonide compound. These compounds are unstable and explosive in nature, so they are not usually isolated, but which can be reduced in situation with zinc dust and water, which gives the aldehyde, because here the cleavage, reductive first cleavage gives aldehyde. There is also another aldehyde, but it's as acetaldehyde, right? So these are the oxidations of alkenes. However, if the ozonides are decomposed only with water, for example, if we cannot take zinc, only water, so this water is connected with O and it is converted into hydrogen peroxide, and this hydrogen peroxide is an oxidizing agent which oxidizes your product into carboxylic acid, right? So that's why we have to use a zinc. Okay, fine. So during this H2O2 produced during the reactions oxidize the initially formed aldehyde into the corresponding acids. So this two-step conversion, mind well, practically this two-step which can be done by one step. Okay, the two-step conversions of an alkene into an ozonide followed by its reductive cleavage to yield carbonyl compound is called as an ozonolysis. This is ozonolysis. What's the importance of this ozonolysis? The important is ozonolysis is the best importance is like that. For ozonolysis is a versatile method, is a widely used method for locating the positions of double bond in alkene, right? In unknown alkene, since no different alkenes gives the same combinations of aldehydes and or ketones. Therefore, this method has been extensively used in the past for the structure identification or the locating of positions of a double bond. For example, if I having a but1ene, right? So ozonolysis at here. So first step is ozonolysis. So O, like okay, then reductive cleavage. So we get the product is like that: CH3, CH2, CHO, and another particularly product is HCHO. So one is propanol and one is methanol. Same way in the case of but2ene. So here the ozonolysis process and then reductive cleavage, which gives CH3 CHO 2 mole, because CH3CHO and CH3CHO 2 mole of ethanol, 2 mole of ethanol. Then for example, if having a 2-methyl propene, so ozonolysis which can be done at this unsaturation, so COOO, right? So we get a product is like that: CH3C, CH3 double bond O, and this HC double bond OH. So one product is ketone and remaining is aldehyde. Same way, I having a 2,3-dimethyl but2ene. So this 2,3-dimethyl but2ene, so reductive cleavage which can be converted into CH3 C double bond O CH3. So 2 mole of acetone, because here ozonolysis ozonide compounds and the reductive cleavage in presence of zinc and water which can convert into acetone. So 2 molecules of acetone which can be formed. Reverse, for example, if I have a 2 mole of acetone, so we have to remove this oxygen and another oxygen and joint. So we get a product is like that: 2,3-dimethyl but2ene. So it's an important method for locating the positions of a double bond in an unknown alkene. So most of the MCQs which can be asked in your competitive examinations like that, a compound A which ozonize in presence of zinc and water gives your product B and C, and B and C are respectively acetone and acetone. So what's your product A? So you have to particularly mention about this A. Okay, what is the meaning of this A and how we can form this particularly compound? Okay, so this is about the ozonolysis reactions. Okay, then after we move to the last one, particularly reactions in alkene is called as a polymerizations reactions. In standard 12th, one lessons about the applied organic chemistry is polymerization. The meaning of polymerizations means what? Polymerizations is such a process in which a large number of simple molecules, for example CH2 double bond CH2 is a simple molecule, propene is also a simple molecule, right? So to form a big molecule, so these simple molecules are called as monomers, and the big molecule is called as a macromolecule or a polymer too. So polymers are extremely useful products, and these particularly have revolution our everyday living. For example, polymers are used as a plastic in textile industries, rubber industries, and many other industries. Alkenes readily undergo polymerizations in the presence of catalyst. For example, if I give you the one more example is ethene, right? So when ethene is heated at 200 degrees centigrade temperature, under a pressure 1500 means 1500 atmospheric pressure, in presence of little bit traces of oxygen, so it undergoes polymerizations and converts into polythene. What are the uses of this polythene? As we know that it's widely used as a packaging material, for example in the form of thin plastic films or bag, etc. Insulations for the electric wires and cables. It is also used for making a squeeze bottles, refrigerator trays, toys, pipes, and radio and TV cabinets, etc. So these are the uses of a polythene. Okay, these are uses of polythene. Same way, polypropylene or polypropylene is prepared by heating propene in presence of peroxide, because here this is a free radical mechanism. Always free radical, which can be done with the help of helper: heat, electricity, light, peroxide, radical, right? So here we have to use a initiator as a peroxide temperature, and or if we take a Ziegler-Natta catalyst in 12th standard, we discuss about the Ziegler-Natta catalyst. Okay, so this Ziegler-Natta catalyst is used, right? And we convert this compound into polypropylene. What's the difference between this polythene and polypropylene? Polypropylene is little bit having a molecular weight is quite good, so they are harder and stronger than polythene. Okay, so that's why polypropylene is used for making milk crates, plastic buckets, automotive moldings, right? Seat covers, carpet, fibers, rope, etc. And sometimes the container for oils and gasoline, which can be also made with the help of this polypropylene. So this is all about the polymerization reactions. So in these portions of alkene, we discuss various reactions like electrophilic additions reactions. In these electrophilic additions reactions, first point is hydrogenations, then halogenations, then hydrohalogenations, then additions of sulfuric acid, means indirect hydrations, and then hydrations is a direct hydration process. So this particular topic that can be studied in our chemical properties of alkene, and mainly is the electrophilic addition. Then we switch over to the oxidations reactions, and then after oxidations, the last point is a polymerization. So this is all about the alkene for our standard 11th hydrocarbon syllabus. In next sessions, we meet with another functional group is called as an alkyne. Thank you very much.